Okay, we have here a mass attached to a spring. At first it's held here with the spring at its unstretched length. When it is let go, this mass will of course go into SHM, at first with an amplitude of 0.29 meters, but because of damping, I suppose, the oscillation will decrease until it comes to rest here. So what is the change in GPE going from here to here? So this part is easy. The change in GPE would simply be mg delta H. So put in the mass, put in the value of G. So we dropped a height of 0.29, right? So the change in height should be a negative 0.29, and from here we get negative 12 joules. So going from here to here, we have lost 12 joules of GPE. But we do gain EPE, elastic potential energy, in going from here to here. And to calculate that, we can make use of the force extension graph. So at first, the extension was 0, and going from here to here, the spring will become stretched by 0.29 meters. And if the spring follows Hooke's law, then it should be a straight line graph. Okay, now what is the force when the spring is stretched by this amount? This is the equilibrium position. At the equilibrium position, the downward weight is balanced by the upward spring force. So at this extension, the spring force should be equals to mg. The amount of EPE that's stored in the spring when it's stretched by this amount should be equals to the area under the force extension graph, so it's this triangular area here. So that's the amount of elastic PE that is gained. So to calculate that, the area of this triangle would be half base times height, right? So half base times the height, which is mg, and mg is 4.2, 9.81. If you compare this with this, you notice that this is simply half of 12. So we obtain a positive 6 joules to be the gain in the elastic potential energy. Of course, it's possible for you to calculate the spring force, the spring constant, by equating kx to be equals to mg, and using the value of k, you can arrive at the same answer. But I think it's faster if you just use the force extension graph and realize that you only gain half the loss in GPE. You might ask, where did the energy go? Of course, there was damping, right? So the energy was lost to the surrounding. Okay, ta-ta!